All right, so we want to quickly look at how you're going to be resolving forces into their components. Remember, the first part would be to use Coulomb's law to get the size of your force. Now, when you have the size of your force, you're going to have to resolve it into its components. And as you are resolving, you are going to need to make sure that the answer you get has the sign also, because we will need that sign when we are adding the components together. So here's the thing. When we are resolving forces, I'm just going to show you something and then we'll go through a few cases and hopefully you'll be good to go. Okay, so here's the thing. When you are resolving forces, I'm going to draw a Cartesian plane. I'm going to put it like this. You know, your Cartesian plane is something that has the x-axis and then it has the y-axis. Okay, so now whenever we are dealing with a charge, remember we'll be trying to find the forces that are acting on one charge, on one charged particle. So we are going to imagine that our charged particle is at the center, is on the origin. So I'm going to just put a charged particle here. We don't care what charge it has inside here. Maybe let me try to erase the inside. Let me put the x's again. They're going to be going like that. And then the inside, I'm going to keep it empty. So we don't care what charge. The charge could be negative. It could be positive, right? We're going to imagine that our charge is at the center of this Cartesian plane, or at the origin. So now when we are going to be dealing with forces, you are going to be having to, if you have your force, let's say wherever your force is acting like that, let's say this is your force. When you are resolving it, you are going to have to turn it to go to the positive part of whatever axis you are dealing with. You know, along the x-axis, this is the positive part, and this is the negative part of your x-axis, right? And then this is the positive part of your y-axis, and this is the negative part of your y-axis. So when I'm dealing with this f, whatever f it is, if it's f1, 2, right, and it has an arrowhead, this arrowhead shows me that the force is still a vector. But when I resolve it to its components, they are not going to be vectors anymore. So this is f12, and I'm going to convert f12 to get it to be in y like this, and I want f12 in y. I still put an arrowhead when it's on the diagram like this. And when I want f12 in x, I'm going to take it to the positive x-axis. So that's a key thing. Remember that. So I'm going to take it to the positive x-axis, which means it's going to be here. And this is going to be f12 in x, okay? And I'll put an arrowhead. This one is still a vector. So that means when I'm resolving my f12 to go to the y, I'm going to go like that, okay, to go to the y. And then to go to the x, I must take it to the x-axis. I can see that if I can go this way, okay, to go to the x-axis, but it's longer than going this way. Okay, the direction you go doesn't matter. I'm going to prove to you just now. But what we're saying is you are going to have to resolve it. And as you're resolving, you are cutting into a certain angle. So that means if I'm to take this f12 to go to the x, I'm going to take it this way. So I'm going to need to know this theta. And then to take it to the y, I'm going to have to know, let me take a different crayon, maybe the white one. I'm going to go this way. And that angle could be alpha. So I'm going to have to know alpha. So to get f12 in y, okay, when I now write it, I don't put the arrowhead because what I'm now getting is going to be a scalar quantity. I'm only going to be getting the size. I'm going to say this would be f12, the original one, then you multiply cos alpha, okay? The angle you cut into to go to the y-axis. Can you see that? And then for x, f12 in x is going to be f12 again, then cos, what is the angle I eat up, or the angle I cut into to go to the x-axis? That angle is going to be theta, right? So it'll be cos theta. I want you to know that if I go this longer way like this to go to the x, okay, and I still get this, so this angle, I might call it phi, okay? If I say f12 in x is equal to f12 like this, then cos phi, I will still get the same answer as cos theta. Okay, just know that if you have two angles that add to give you 360, their causes will be the same, because this theta and this phi together, they give me 360. So cos of theta is the same as cos of phi, so it doesn't matter. But when you are writing, you're going to see this if you go through your lecture notes. When you are writing, theta, the smaller one, is the one we prefer. Okay, we prefer you use the shorter way, and that doesn't change the sign of your angle. Your angle is just going to be positive because we are only going to take the size. We are not saying, oh, when I'm going this way, my angle will be negative. When I'm going that way, it's positive. No, we just look at the size of the angle, and that's done. Okay, so just remember this part. Let's go through some examples, and I'm going to show you. So now let's say you have this force acting straight up. Remember, now I'm going to be ignoring the negative x's. These guys is gone because I don't care about the negative parts. I'm going to be using the positive x's because I want them to be with regards to the positive. So the positive y and the positive x. So now when I have a force which is acting, here is my particle on the origin. Let's say it's particle B, it's called PB, particle B. So there's another particle x somewhere that is acting on B, so that we have force xb, which means force by particle x on particle B. Now, let's say I know it. I would have found it using Coulomb's law, right? But now I want to find its components. You're going to see us do this in the examples that follow. To find its components, I'll say I want fxb in the x1, okay? And then I want fxb, the y1, okay? And the x1, remember, we don't put the arrowhead. Sorry for this one. We don't put the arrowhead. It's now going to be what? Fxb in x is going to be fxb, the original one, okay? And then cos this angle, the angle that you move like to go to the positive x-axis, and we know that it's 90 degrees. So it will be fxb cos 90 degrees. And you're going to find that cos 90 is 0. So your answer in here, your total answer would just be 0. So that means this fxb is not acting in the x direction. It's only pulling somebody straight up. Straight up. Okay, now what about in the y? In the y is going to be fxb, the real one, okay? And then cos 0, okay, 0 degrees. So it's just fxb total. Cos 0 is 1. So you're going to see that cos 0 is 1. So you're just going to get it as fxb. So fxb in the y is just equal to fxb times 1, right? This vector times 1. And you get fxb in the y. Okay, you'll be done. That's how you do it. Now let's go to another example. What about if it's acting in the x? What would you do? Well, same thing. We do the same thing, class. We do the same thing. Remember, this is your y-axis and this is your x-axis. To get a component, you have to know the angle it makes with the positive version of that axis. So I'm going to have fyb, right? I wish I could call it fzb. So if I want fyb in x, this is going to be fyb, the true one, which is this one that I find using Coulomb's law. And then I say cos 0 degrees. And cos 0 degrees is 1 because the angle with the x-axis is 0. And then I'll get fyb in y is equal to fyb, the original one, cos. What is the angle that it's making with the positive x-axis? It's a right angle. It's 90 degrees. So it'll be cos 90 degrees. Remember, I don't care which direction it's acting. I just want the size of the angle. So this would give me 0 because cos 90 is 0. So my answer here will be 0. Let's look at another example. What about when you have a situation like this? Now, I'm going to show you two things on this situation. One of the things is what we're going to use right now. And in the first situation, when you have basic force and you want to find the force acting on one particle. And then on the other one, we're going to use it when we do the superposition. Okay. Now, what would I do? So I'm going to let me just put another one. Same thing here. And I'll show you two ways of getting your answers still the same. Right? So this will be the, oh my, I mislabeled my x's. I'm going to say that this is going to be, where is my eraser? I'm going to do this. This is the x and this is the y. This is the y and this is the x. I have a force that is now slanted, and that force is called FAB, and it is acting at an angle of 30 degrees. So now I want to find its components. Now, slanted forces, the reason why this force is slanted is because it's doing two things. It's pulling some along the horizontal, and it's pulling somebody up at the same time. That's the reason why it's slanted. So I know definitely I'm going to get something for f in y and then for in x. So let's see how we get it. I'm going to start with the first one. This first way of getting your solutions is the one we've been doing all along. I'm going to say if I want FAB in x, I'm going to see, remember, I don't put an arrowhead for that. I'm going to see the angle it is making with the positive x-axis. And what angle is that? 30 degrees. So it's going to be FAB, the original, then cos 30 degrees. Then cos 30 degrees. If I now want FAB in y, okay, this is going to be FAB. Then I need to know the angle it makes with y. Now I know there is 90 degrees between these guys. There is 30 here, so definitely in here is going to be 30 minus 90 minus 30, you get 60. So it's going to be 60. So I know FAB in y is going to be FAB cos 60 degrees, because you are going to have the angle with the positive y-axis that your force is, and you just cos. You would have gotten your answers, and that's how you do it. Now, when we are resolving in the other way, you can see us do this. To find my FAB in x, this is going to be the same thing, FAB, right? Then cos 30 degrees, right? And this is the original FAB. Then now the vector one, FAB in y is going to be, now this is what we do in another way, especially for forces that are slanted in the first quadrant like this. That have small angles, both 30 degrees, 45 degrees. We can do this. What are we going to do? To find the one in the y, we say when you are closing into your angle, you say cos, right? When you're closing into your angle, you say cos. When you are opening away from your angle, because now to go to the y, you want this FAB, you want it to stand upright like this. You want it to be acting in the y direction, to be straight up. So that means you are pulling this line to go there. Now we are opening away from the angle that you know. You are no longer going with an angle that you know. The angle that you know is this 30. You are now going away, so you use sine. When you are closing into the angle, you use cos, because cos is inside. So if I pull this down, I'm closing that angle. But if I pull it up, I'm pulling away. So it will be FAB sine 30 degrees. It's only for this guy in the first quadrant. That's what we're going to do. We're not going to do it anywhere else. Make sure you know that. We're only going to do it with these type of forces that will be in the first quadrant like that. Okay? But this method is what we are going to be using for the first few examples, where we need to know the angle it makes with that particular axis. If you want FAB in y, you must know the angle it makes with y. In this case, we did not know that angle. We just used sine. We knew this 30. You get the same answer. So now let's see. What if I have a situation like this? These are nicer situations that we're going to. Almost done. What if I have a situation like this? It's facing away like that. How would I get my components? This is the y-axis. This is the x. I know that here with the y is going to make an angle of 90 degrees. And I know that with the x is going to make 180. Whichever way I go, even if I go this other way, it's going to be 180 still. I like the shortest path. So it's 180 either way. So if I'm going to find FCB, this is FCB, the vector. If I'm going to find FCB in x, this is going to be FCB, right, the vector, then cos 180 degrees. Okay, that's the angle it's making with the positive x-axis, with this positive x-axis over here. Now, what if I want FCB in y? This is going to be equal to FCB, the vector. Then what? What is the angle it's making with the y-axis? Class, it's making an angle of 90, so cos 90 degrees. And this will give you an answer of 0, because cos 90, you put in the calculator. Make sure your calculator is in degree mode, is 0. So already I am seeing that if a force is lying flat, like in the direction where horizontal, it will never do anything up or down. It will never do anything up or down. And if a force is facing straight up, it will never do anything in the horizontal. So that's why this guy is 0 in the y, because he is flat. So sometimes you might see them not even calculated, because they know in the y this guy will do nothing, because he is lying flat. So he's going to just pull something flatly, horizontally. It has no impact on its motion up or down. Now let's see FDB. FDB, we want to find its components again. We already know from experience that it's not going to do anything in the x, because it's facing straight up or down. It's facing straight down, so there's no way it's going to make something go to the right or to the left. But still, we can calculate it, okay? If you can, but sometimes you see them not doing it. So if I want FDB in the, sometimes to save space or time, you could just ignore it. Okay, let me prove it to you. FDB in the x is equal to FDB the one that you have, and then you say cos. What is the angle it makes here? It's 90. It's 90. The angle it makes with the x-axis. We can also use this one, which is going to be 270. You get the same answer, but we don't like to use 270, the bigger one. We like to use the smaller one, which is 90. So it's going to be cos 90 degrees, and this would just be 0. Now to get FDB in the y, this is going to be, look at the reason. Don't forget not to put an arrowhead here. Please don't make such mistakes. FDB in the y is going to be FDB, the original one, then cos. What is the angle it makes with the positive y-axis? This angle is going to be 180 degrees. Okay, we know that. So it's going to be FDB cos 180. Okay, and you are going to get your answer. I think cos 180 is going to be -1 or something. So it's going to be FDB, the original FDB, and then times -1. So you get your solution. There we go. Now we go to the next. Look at this one. What if it's facing there and it has an angle of 145? This is quite rare, but we're just going to do it anyway. It's quite rare, but we're going to do it y and x. What would I do in this case? Well, I know if it's making 145 with my x-axis, I can also get what it's making with my y-axis, because I'm just going to remove 90 degrees from there, right? That's all you do. You have to know that. So if you say 145, minus 90, you must get 55. So you know it's going to make an angle here of 55 degrees. So if I'm to find, this is f what? ZB. Okay. So I have FZB. If I want to find in x, this is going to be FZB, like that, the real one. Then I say cos. What is this angle? 145. Yes, 145 degrees will be smaller than this bigger one. Okay, so it's fine. I'm going to use that one, cos 145. That's the angle it makes with the positive x-axis. That's the angle 145 with the positive x-axis. Now if I want to find FZB in y, it's going to be, I'm sure now you're getting the thing, FZB, the original one, then cos 55 degrees. You are done. Okay, you have put with the positive y-axis. We always use the positive version of the axis of that guy. So I think these are the last two examples. Yeah, two more examples, then we're done. So this is y and this is x. If I want to find FKB in x, so I can say I want to find FKB in x. This is going to be FKB, the original one. And then what is the angle it's making with the x-axis? 230. Oh no, 230 is too long. I know this one will be shorter. Let's try. We say 360 minus 230. We get 130. So this is 130. We use that. So it'll be cos 130. We know though that cos 130 and your cos 230 will be the same. You might not get these type of angles, these 230. You might get nice ones like 90, 45 and stuff. So just know that. But I'm just putting so that you know the situation in any case, whatever is to happen. Now, if you were to find FKB in y, this is going to be equal to FKB, this, the vector, then times cos. What is the angle it makes with the positive y-axis? I'm going to say 230 minus 90. What would I get? I get 140. So it's making 140. I have removed this 90. That is why. Okay? I've removed that 90. So I'll get 140. So it'll be cos 140 degrees. And you are done. That's how you do it. Now the last one, what if it's like this, 320? Therefore we know that this is going to be 40 degrees because it must be 360 in total. So if I want to get my FJB in x, I know it's going to be FJB, this one, I say cosine of 40 degrees. If I want to find FJB in y, it's going to be FJB again. Then to go to the y-axis, what is the shortest way? This is 40 plus 90. If you would say that, you must get like 130. So this will be like 130 degrees. So I think that's the shortest. It's shorter than the other one. So it's definitely cos 130 degrees. You have taken it to the y and you'll get your solutions. That's it. Thank you for watching. Goodbye for now. See you in the next video.